Okay, so now we're going to look at a type of stoichiometry problem called a limiting reactant or limiting reagent problem. When we first learned about stoichiometry, you were given a quantity of one thing in the chemical reaction that you used as your known. In the limiting reagent problem, the difference comes in is that we know quantities typically of both reactants. So instead of having one quantity that we start with, we actually have two. In this case, we have 0.855 grams of Cl2 and 3.0205 grams of KBr. So what's going to happen here is similar to what happened with the nuts and bolts. If I have a fixed amount of both reactants, nuts and bolts, I know that one of them is probably going to run out before the other. And that's going to limit how many products I get. So we can do the same thing with chemistry. With these two quantities of reactants, one of them will run out before the other. When one runs out, then you can't make any more products and the reaction stops. So the first thing we have to do is figure out, well, what's going to run out first, because that will determine how much product, in this case Br2, is formed. So we can still use a BCA table to figure this out. So I write the letters B, C, A, and I know that I cannot put grams in the BCA table. You have to put moles in the BCA table. So 0.855 grams of Cl2. I'm going to convert that to moles. And that's 0.0121 moles. So that's how much Cl2 I start with. And if I have 3.025 grams of KBr, KBr, 1 mole of that is 119.0 grams. So that tells me I have 0.02542 moles of KBr. So those are my two starting numbers of moles. So since I have two starting numbers of moles, I can put them both in the before row of the BCA table. So that's 0.0121, and that's 0.02542. So I know I'm starting with both of those quantities, and I also know I'm not starting with any Br2. I'm not going to worry about KCl because that's not asked about in this problem. So in the limiting reactant problem, one of the reactants is going to run out first, which on the BCA table means one of them will go to 0 first. So I'm not really sure which one's going to go to 0, so I'm just going to say, oh, I think KBr is going to go to 0. So if KBr goes to 0, I'm just making a guess. I just picked that one because it's first. I don't know for sure that it's going to 0. But if it did, then I could figure out, well, how much chlorine got used up. And I can do that by taking that 0.02542 and multiplying it by the ratio 1/2. The column I'm in over the column that the 0.0252 came from. So if I do this math, 0.0121, and I subtract out this, which is actually equal to 0.0127, I end up with an after amount of negative 0.00606 moles. So it is impossible to have a negative amount of stuff at the end of the reaction. The least amount of stuff you can have at the end of the reaction is 0. So the fact that I got a negative under Cl2 means that I picked the wrong thing as the limiting reactant. It's not the KBr that's the limiting reactant. It's the Cl2 that's the limiting reactant. So now what I have to do, instead of zeroing out the KBr, I'm going to zero out the Cl2. So let me erase this. And now, instead, I'm going to restart my BCA table, but this time I'm going to make Cl2 go to 0. So now my Cl2 goes to 0. And so over here, since that's going to 0, that's the number that goes there. The ratio is 2 over 1. And when I do this math, so I take this number, subtract it from that, I get 0.00122. So what this tells me right now is that when I have no more chlorine gas, I still have 0.00122 moles of KBr left over. So there is still some KBr in the reaction. There just isn't any chlorine to react with it. Now, since the chlorine is the thing that goes to 0, that means on this other side, I'm going to add 0.0121, and that ratio is 1 over 1 because both of those coefficients are 1. So that means I'm going to produce 0.0121 moles of Br2. So the question asks how many grams of Br2 are formed. So I would just take this number of moles of Br2, and that's moles. I know 1 mole is 159.8 grams, and that tells me that 1.93 grams of Br2 is produced. So that answers the second question, how many grams of Br2 are produced. The first question, which is the limiting reactant? Cl2 is the limiting reactant. So it goes to 0. That's how I know it's the limiting reactant. So the thing that goes to 0 is limiting. The other reactant that has some left over is called the excess reagent. So let's go ahead and look at one more limiting reactant problem. So here I have a single replacement reaction. So I'm going to start with 22.9 grams of nickel and 112 grams of silver nitrate and try to figure out how much nickel 2 nitrate is produced. So BCA right there. Now I have to take nickel and silver nitrate and convert them to moles. So 22.9 grams of nickel. 1 mole is 58.69 grams. So that's 0.390 moles. Silver nitrate, I have 112 grams of silver nitrate. And 1 mole of that is 169.88. So that means I have 0.659 moles of that. So now I can put these numbers up here. So this is 0.659. Nickel is 0.390. So again, one of those is going to go to 0. And I'm going to pick silver nitrate. So if I make silver nitrate go to 0, that means I lose 0.659 times 1 over 2 moles of nickel. Now when I do this math, 0.659 divided by 2 basically, this number ends up being 0.330 moles. So 0.39 minus 0.33 is 0.060 moles. Since that is a positive number, I have chosen the correct thing to be the limiting reagent. So silver nitrate is limiting. So that's going to limit how much nickel nitrate, nickel 2 nitrate I get. So over on the nickel 2 nitrate side, I know I'm starting with 0, and I'm going to add 0.659 times 1 over 2, which again is 0.330. So that tells me I'm going to make 0.330 moles of nickel 2 nitrate. So 0.330 moles of nickel 2 nitrate. Yep, running out of room. 1 mole is 182.71 grams. So that gives you 60.3 grams of nickel 2 nitrate is what I produce. Because once I produce that much, all the silver nitrate is gone. Silver nitrate has gone to 0. Now let's look at the second question. How much excess reagent is left? Well, if I look, I have 0.060 moles of nickel left over.
Mr. Lloyd, please dial 85148. Mike Lloyd, please dial 85148. Thank you.
So now what I'm going to do is convert that to grams, and that will tell me how much is left over. 58.69 grams in 1 mole, and that is 3.5 grams of nickel. So that tells me at the end of the reaction, after I've used up all 112 grams of silver nitrate, I still have 3.5 grams of nickel left over.